this video, I'll talk about how buses are categorized, like when you're talking about steady state power flow. So, there are kind of three types. So you have the swing bus, PQ bus, and PV bus. So for the swing bus, so you have two nouns or two known variables and two unknown variables. So in general, you have voltage, power angle, then you have P, and you have Q. So two out of these four are known and two are unknown at any given bus. So if you have a swing bus, so swing bus or slack bus. So for a swing bus, for instance, voltage is typically known, say like 1 per unit, and the angle is 0, for instance, degrees. So they are known. Then you don't know P and Q, so which they need to be calculated from the power flow analysis. If you have a PQ bus, so then P and Q are known, like a load, for instance, but you don't know voltage or the angle at that bus. So those two need to be calculated from the iterative process, which is what power flow does. So then you have PV bus. So basically you have P and V, so active power or watts are known, voltage is known, but then you have to calculate Q, VARs or reactive power, and the angle. Let me just get rid of this here so it's not in the way. So each, as I said before, each bus falls under one of these buses. So swing, slack bus, load PQ, or voltage controlled PV bus. So the swing bus or the slack bus, it's typically one of the largest generators. If you have a large system like the North American system, you might have multiple swing buses, like one for each area, for instance. So basically what the swing bus does is, for any losses, that occur in the lines, for instance, they will pick up those, or they will supply those losses for, also if a generator is lost due to an outage, for instance, or if you are performing contingency analysis, you are taking outage in one thing at a time, for instance, and you're trying to see if the system will be secure or reliable. If you lose a generator, for instance, that power has to be compensated from, so the swing bus will provide that extra power that's needed, because at any given time, generation has to equal the load you're supplying plus the losses. And just to make it simple, the losses are I squared R, basically, because transmission lines or feeders, they have resistance, which cause I squared R losses. So at any given time, this equation have to be balanced, or it has to be maintained. So that the swing bus basically will provide any losses, or if you lose one of the generators that is providing power for the load, but the load was not reduced, that means you have to increase generation. So that's where the swing bus will come in. So then you have a load bus. So PQ, basically you have a load, you know how much power it draws, and but then you don't know voltage and the angle, as mentioned previously. Then voltage controlled or PV bus. So at each bus, two of the variables are specified as input data. So they are given, or they are known, as mentioned before, and two of those variables they are not known, so they need to be calculated by the power flow program. So swing bus or slack bus is one generator. Typically is the largest, and if you have nuclear, it might be nuclear, the nuclear plant or generator. So load PQ. So then you have voltage controlled bus. So typically generators, they have the capability of controlling the voltage. Switch shunt capacitors, capacitors basically, statcoms, SVCs, or a bus with transformer tap changer to increase the taps or decrease the taps to boost or buck the voltage basically. So if the calculated Q is less than the Q min, then the program basically would set the Q calculated to the Q min, because each generator has a limit. So if you take any generator, it has a range. So it has a Q min, the minimum Q that it will supply, and it has Q max. And the same thing for P. And by Q, I mean the reactive power basically. Reactive power. The units are VARs, kVARs, kilovars basically, or if you have a large system, megavars. So the generator will operate within this range. That's like if you wanted to operate safely. So as the power flow calculates Q, because here, if we have a PV bus, Q is not known, so it has to be calculated. But if that calculated Q is smaller than the Q min, then what the program would do is set the Q calculates to the minimum, then recalculate basically, and change the bus to PQ. So then what it will do, because now Q is kind of like a known, so it will set it as PQ. Let me erase just so it's not confusing. All right, so now also, so that's for Q min. Now for Q max, so again, for a PV bus, P is known, V is known, but we don't know Q. So the program will calculate Q. So however, if Q calculated happens to be greater than the max or Q max, then the program will set Q calculated equal to Q max, and it will change the bus to PQ instead of PV. So hopefully this video is kind of like a quick introduction to power flow. So hopefully it clarified the how the buses are categorized, when you're dealing with power flow. Thank you and have a great day.